Being from West Virginia, we're going to keep things simple. This means yes. This means no. This means I have no clue and you've lost. Rule number 2, there is no such thing as a stupid question. Only a question you keep to yourself. So before we get started, how many of you all know what you're looking at when you look at a lithium-ion battery? That's cheating. The folks over here are not allowed to answer. You all have heard of inclusion. We're practicing educational exclusion. How many of you all got earbuds? No, see, you didn't know there'd be an exercise program. Keep your hands up. You realize you're putting a lithium-ion battery in your ear? Are you aware that according to the American College of Emergency Physicians, they treated over 14,000 injuries in the United States related to earbud injuries? Are you aware that that's 60 times more than anything related to other lithium-ion batteries? Oh my God. How many of y'all got a cell phone? Again, more part of the exercise program. If you want to balance them out, change it into arm day. You do it too much, you come to West Virginia, we're going to think you're a goose flying south. But what if I told you last year there were almost 27,000 incidents involving cell phones? Oh my God. My statistics are correct, right? So, but everybody, all of a sudden now there's this panic about EVs and other stuff, and we don't understand how much this technology has permeated our lives. So I want you to shift gears. Ron, Chief Ketterman, did a great job talking about the impact on the FDNY. And there are 3 commandments of lithium-ion batteries I want you to know. So we get started. 1, the lithium-ion battery you buy for that product is designed to work with the battery that came with that product. And it is designed to charge at a specific rate over a specific period of time under specific conditions, which is why they give you this little thing called an owner's manual. Which, we being guys, what's that mean? We don't need that. Rule number 2, never underestimate the power of a redneck in a tool set. Because I can fix it. I go buy my, I'm going to pick on Volvo, go buy my Volvo, and I buy everything, and they put the home charging kit in the back. And I've spent all this money, and they tell you, sir, what's your first name? Jason. Hi, Jason. Thank you very much for your purchase of your Volvo. By the way, you have to take this thing home, and you got to charge it, and you're going to have to install this program. And it's going to cost you about $1,500 to have an electrician put it in. You're probably going to have to get a building permit, which in the city of Charleston, West Virginia, where I come from, is going to cost you $175. And by the way, we want you to be on a dedicated circuit, so when you have, how many amp is your service in your house? Oh, by the way, you probably want to be on at least a 200 amp service. Have it on a 220 volt thing. Please park it like this. So you go home and you go, I got my cousins Larry, Harry, and Daryl, and my other brother Daryl, and he wired up the lights out to my tool shed. I'm going to bring him in here. And he looks at you, and what was your name again? He's going to say, Jason, you don't need all that stuff. By God, we'll just wire it up there to the dryer in the garage. So then Mrs. Jason comes out and she wants to dry clothes while you're charging your car. And then we have a problem. Rule number 3, commandment number 3. These batteries are designed just like any other mechanical device. They have operating conditions. So being a purveyor of mud hole chemistry, what is this in its simplest form? No, it's not a bottle. Come on, no hazmat people in the building? Who said it? You get extra credit. It's a container. And like any and all containers, it has designed, engineered, and built-in safeties. What is the designed, engineered, and built-in safety for this container? The lid. Which, under proper conditions, I turn it sideways, the safety works, right? just like an electric vehicle, just like any other mechanical device. So is that electric vehicle designed, and the safeties inside that battery, designed to work when the car ends up on its top? Yeah, maybe, but probably not. What about if it goes 130 miles an hour sideways into a telephone pole and you have 42 inches of intrusion into the battery compartment? So then why is it the car's fault? Huh? The news articles say Tesla burst into flames. It doesn't say driver was driving like an idiot, went 130 miles an hour sideways into a telephone pole. It doesn't say that. So I want you to shift your paradigm. Now Chief Kennerman talked about all the different types of vehicles and everything else, and there's all kinds of different battery configurations, battery formats, battery voltages. You know, there's your car typically is 100 kilowatt hours. Remember he talked about kilowatt hours, and remember how their standards are less than 50 kilowatt hours. Certain things much bigger than that. Much bigger than that. So, how many of you all as inspectors, and I see yours says tech.
Just three.
Okay, but I'm not picking on you. Please, if I say something and I offend you, I'm sorry. You have the right to throw objects at me. In West Virginia, we call that, friendship. But how many of you all would know of a lithium-ion battery if you recognized it? If you walked into a house right now, or a business, and I'm going to use this bathroom down the hallway. Yes or no? Is there a lithium-ion battery in there? What do you think powers the electric eye that flushes the commode? So why all of a sudden did this become a problem whenever they came to cars? So, large-scale battery storage. How many of you all, when I mentioned it earlier, did anybody actually Google Morris, Illinois? Nobody did. You did. 100 tons of these things were stored in a school building. What if I told you the Coast Guard issued a warning in 2017 about waste batteries? Oh yeah.
You can pass it around.
These are different types of cells for different applications. I'm going to start one way back here in the back. See, I get an exercise program too. Different types. Different fold. And tell you how I got started in lithium-ion batteries, because Chief Kennerman gave his story. I did some work for Uncle Sam, and we fooled with lithium-ion batteries back. What if I told you we fooled with lithium-ion batteries back in the early 1990s? I did some training at NASA, and my good friend Rob Cotterman, he was sitting there and telling me, he said, people making fun of giving Elon Musk credit. We got into the lithium-ion battery electric vehicle market back in the 60s. He said, do you think there was an Exxon station on the moon? So what do you think helped power the lunar rover? Of course, they use different technology, different stuff. But West Virginia University formed what was called the National Alternative Fuels Training Consortium, and I became one of their lead instructors in 2006. So we've been doing 16 years. CNG vehicles, LPG vehicles, hydrogen technology. We've even got a cutaway Prius. Looking to get new props like other cutaway cars, but I've driven it in parades. What? But I've driven this car in parades. It's a cutaway car. You can see all the high voltage cables and everything else, and it's really cool. I know people in southern West Virginia put an inspection sticker on it and drive it. But you go to these are becoming really big. They're called battery banks. The largest one I know of is in the Mojave Desert on solar panels. It has about 1,400 of these type cellular banks. They're basically a Connex box that has battery banks inside of it. Different cooling systems on them, stuff like that. There you see another large one up here, up there in the upper left. There you see an e-bike. After Hurricane Ian, they were parking cars. Insurance companies were towing cars and parking them like on the parking lot of Daytona Raceway, other parking lots. And they noticed that they started bursting on fire, and everybody's blaming the car. Well, it's not the car. It's simple chemistry. How many of you all have seen all the stuff on the internet about lithium mines? Yeah, how awful they are and all this other stuff. Well, I'm not saying they're not. But I am telling you that a great deal of lithium that's used in industrial processes comes from salt water, sea brine. Lithium has atomic number 3. It's the lightest metal known to man. But it's like all those other little, rare earth metals. It don't like water. It don't get along. So if you immerse this thing in water, the lithium battery in water, well, salt water corrodes. So the salt water corrodes the technology, the safeties, and moisture permeates the battery cell. And then you get a thermal reaction. Not the car's fault. Don't park your car in a hurricane. Don't drive through water. How many of you all have heard, turn around, don't drown? Well, even applies to Teslas. So, like all alkali metals, it's highly reactive. If I took sheets and filmed of aluminum, and like this battery that they're passing around, it's real thin sheets. It's actually micromils. If I put that in water, there's going to be a reaction. Maybe slow, maybe violent, but it's going to be an exothermic reaction. It's going to give off energy and going to give off heat. You are not going to find lithium free in nature. It's bound with something. And the reason why I'm talking to you this about as prevention professionals, when you're talking to the community, remember when she said when she was reading about my bio about there's no glory in fighting a fire could be prevented? One of the things we're going to have to start doing is educating people when they go buy their DeWalt drill, spend the extra money and buy the DeWalt battery. Don't go to Amazon.com or Wish.com, and I'm not knocking those two companies. But if you want to see how bad it is, go to Wish.com and Google UL stickers. You can get UL approved stickers. You can get a roll of 1,000 of them for I think it's like $40. UL approved stickers, and I can go put it on there. And what are you going to do as an inspector when you see that UL? No, I'm sorry. He's eating. I'm picking on him. Anybody else in here an inspector? Come on. I see everybody going, I'm not raising my hand. He'll pick on me. So, Jason, man, he threw you under the bus faster than a raccoon on Route 50 in Logan County. If you see a UL sticker on something, are you going to question it? Are you actually going to go to the UL website and see the certification number and say, UL certificate 42L1797, is that really valid? Well, my gosh, that's on a toaster. What the heck is that doing on a home energy pack? So, it affects everything we do. Law enforcement, fire, EMS. I did a training last week for the Maryland Safety Institute on EMS. Do you understand that the weights of these electric vehicles directly impacts mechanism of injury? The weight of that battery. So that Tesla Model 3, and again, I'm not picking on Tesla, slams into that Toyota Corolla. You have major weight differentials, and the mechanical forces on that person are much greater than if it was a regular vehicle. Again, fire, EMS, hazmat? How many of you all have ever seen the fire versus, is it a fire incident or is it a hazmat incident? See, I'm on the hazmat side. Like I said, I'm a purveyor of mud hole chemistry. What now? It hasn't affected me at all. So, I've heard people talk about, well, the toxic runoff. If we fight a fire, we're dealing with toxic runoff. Well, who says it's toxic? Who says it's more toxic than a regular vehicle fire? Yeah. I challenge you, I don't care whether it's a Tesla, a Honda, a Mercedes-Benz, an electric bus, you put water on it to extinguish it, you show me where one is more toxic than another. You have to understand the chemistry of burning plastics. Burning plastics give off all kinds of nasty stuff, including hydrogen cyanide, organic carcinogens, all this other stuff. And I don't know, did anybody tell you that there's flammable refrigerants in modern cars? Isobutane, things like that. And they give off the same stuff that a burning battery gives off, hydrogen fluoride and phosphoryl fluoride. So everybody, my question to you, to challenge you as prevention and educators is, are we looking for a reason to challenge it? Are we looking for a reason to make a mountain out of a molehill? Is it a risk? Yes. Is it a challenge? Yes. I will not argue that anywhere on anything. But is it so atypical and so deadly that we have to do that, break out the silver bullets, wooden stakes, and garlic as a fire service to deal with it? No. We've got to rise to the challenge. But it's not just us. We've got the whole continuum that has to change. We've got to change the whole continuum. And we've got to change where we educate. You heard in the video that Chief Canterman showed where the FDNY said they're all hazards, they're an all hazards department. Anybody know when FEMA and the U.S. Fire Academy started teaching all hazards planning? Anybody know? What if I told you the first document came out in 1996? You know how I know? I was sitting in the room when it was done. It was after a little thing somebody was in all the papers called Oklahoma City. And 2 years after that first World Trade Center bombing in 1993, when they said if it can't be shot, handcuffed, or thrown in the back of an ambulance, we're going to send a fire truck after it. So they started talking about all hazards planning. Well, this is just another hazard we have to plan for. It starts with a risk assessment. How many of you all have done a community risk assessment? I drove in here today and I told you how I counted 11 electrical bikes parked at things just on the route that I drove in. I counted how many known electrical vehicles I passed. Why? Because I'm a risk manager. In my paying job, I'm responsible for the administrative, physical, and technical safeguards that protect state government in West Virginia. Everything from terrorism to militias to eco-protesters to everything else. I sat on a panel with the National Science Foundation at the University of Alabama, their School of Engineering. And what if I told you that there is documented chatter among people that would like to do us harm about lithium-ion battery technology being used as an initiator or an instigator for a much larger type device. You've got to broaden your thinking. Everybody's focusing right here. You guys are over here. Chief Canterman talked about this. Gentleman here, he's responsible for this. We're doing some training here, but how many of you all have got an SOP or an SOG, or have actually, before you've done that, gone out and conducted the risk assessment? Here's some ways you can do your risk assessment. Contact the Department of Motor Vehicles, give them the zip code of your district, and ask them how many electric vehicles are registered in your area. Stop at your local auto body shops and your mechanical repair shops and ask them how many, can be anecdotal, how many of these you deal with on a day. Contact the local railroad or ask rail and get a commodity list of how many of these things go through your area on rail cars every day. If you are a legitimate emergency response organization, you can get that data. It's called a commodity report. Go to the local car dealership and ask them, hey, Billy Bob here at Billy Bob's Auto, how many of these do you sell versus how many of these you sell? West Virginia University got started into it real big because of the number of e-bikes on campus. If you want a basic SOP or SOG, you can go to the National Volunteer Fire Council. We have a free one that's in Word that you can just, find name of your fire department, put your name in here, and, substitute. I have to get my 16-year-old son to do it because I'm not very technically savvy. I struggle with on-off buttons. But it gives you a start, so you can at least say you have a policy. You have a procedure. You got to start somewhere. So a little bit about the technology. Not going to go into it very much. I are not an engineer, and I slept at a Marriott last night, not a Holiday Inn Express. I know that electricity and I do not get along. We have a mutual agreement to stay away from each other. But it's basically, there's a cathode, an electrolyte. They're not, all lithium-ion batteries are not the same. There's lithium manganese phosphate, there's lithium iron, there's lithium this, lithium cobalt oxide, all kinds of different stuff. And through that process of the exchange of electrons, it generates electricity. Now, the nice thing is, it's rechargeable. There's lithium metal batteries, like you go down there and buy your Energizer battery. Oh, this has everyone seen this? Up, front row. There we go.
That's exactly what that is, but there is a lot of them.
But the thing is it allows the free exchange to go back the other way to recharge and rebuild the cell. Did I cover that basically? Now, during this process, heat is generated. These batteries operate between, depending on the manufacturer, between like 130 degrees Fahrenheit, 170 degrees Fahrenheit. Some operate, industrial batteries may operate in the 200 range. So, you're an inspector, right? No. Don't do nothing. Anybody in here an inspector? Again, second chance. What if I told you to do your inspections with a thermal imaging camera? So when you go to that, guy's got his Generac system, and again, I'm not picking on Generac. Any name brands I say here, for the disclaimer, is I'm not throwing them under the bus. But you go do their Generac system. What if I told you to just walk by with a thermal imaging camera, and if you see a temperature greater than 200 degrees, you probably need to talk to them about it. Could be a problem. Again, here's different types of batteries. All these things, the lithium ferric phosphate thing, they say, oh, they're the best. Okay. Well, then you go talk to Samsung and they say, our battery's the best.
Just the distance.
What now?
Just a different recipe.
It's a different recipe of cooking the same stew. Electricity. Different things. There's lithium, cobalt oxide, manganese oxide, iron phosphate, lithium, nickel manganese. And just so you know, according to the International Energy Commission, which is part of the UN, there's about 70 to 80 different technologies out there, and there's even new ones coming out every day. The issue becomes on feasibility of manufacture, practical applicability, service length, service use, all these different things. But there's different stuff out there. Again, other technologies, where they're used at. Now, they may be used in other applications, but just to give you a thing. And by the way, we've turned this presentation over, and I understand, is that correct, Teresa? Everybody's going to be able to get a copy of it? Yep. So, don't worry, share it. Different voltages. This is particularly for portable tools, things like that. Again, different things. You'll notice there's what's called emulsion layers. There's layer, electrolyte, layer, emulsion. If you roll them out, or, which I like to do, I like to blow them up, you'll see all that stuff come apart. They would not let me blow stuff up at NASA. Still haven't gotten over that. It was just fine at Aberdeen Proving Grounds, but NASA, no, might blow up the expensive spaceship. But there's so much more than cars. He talked about electric scooters. Okay? What about at your local Walmart? Got the motorized chair there? See, Walmart got an education last year outside of Indianapolis. See, they had a $1.2 billion lesson in going with the low bidder. They converted all their forklifts from propane to electric batteries. But then they did exactly what Chief Canterman said not to do. Jeffords Corporation, who has the contract for batteries for Walmart, said this is the type of battery you need to do. Well, this company that has a contract with Walmart for that stuff said, oh no, we can get those batteries much cheaper. We can go on, Billy Bob's and buy them from Trashcanistan and plug them in, they'll work. Oh, they worked into a $1.2 billion urban renewal project. Correct? You've heard of this incident? And the guy says, well, maybe you know what the difference in price was? For a $1.2 billion thing, the difference in price was actually $12,400. That's a pretty good return on investment, isn't it? You guys would be happy with that, wouldn't you? Your stockholders would be thrilled with that. What about that? If I told you electric vehicles, my good friend from Kansas, Steve Hurst, cried when he saw this. What if I told you that tractor weighs 62,000 pounds? So where does that come into play in terms of rescue? Anybody in Western Maryland, you guys ever do farm rescue classes? So what if you go break out your 20-ton airbag to go pick the tractor up off Grandpa Farmer, but it worked on all the other John Deere tractors? What if I told you that John Deere tractor operated between 550 kilowatt hours of energy and 1,200 kilowatt hours of energy? And what if I told you that John Deere in its testing thing says that thing will arc 3 feet? Whoa. School buses? Construction equipment, city buses, forklifts. It's everywhere. So, how many of you all have ever heard the term 18605 cells? Again, you cannot answer. It's like a AA battery on steroids. Right. The 18 has to do with the diameter. It's 18 millimeters. 605 it's 60.5 centimeters long. Just like those of you who hunt or play with ammunition, 7.62 by 39, 7.62 by 51. See, where I'm normally teaching the South, rednecks get it right away. Oh, yay, yay. Got me one of them. Got me one of them 30-round mag. No. Well, I want you to think, in an electric vehicle, now these are all hooked up in series. Notice the connection. They're all hooked up in series. What if I told you in an electric vehicle, a Tesla Model 3, there's 7,000 of them? You go back to John Deere tractor. What if I told you there were close to 40,000 stacked in series? Just so you know, the battery goes here and it actually goes underneath the tractor, right above the drivetrain. It's not all just in the engine compartment. There's different configurations. This is a Ford Focus. Anything with orange is high voltage. Anything with orange is high voltage, which for me, coming from where I come from, means keep your hands off of it. And how many of you all have raised kids? Raise your hands. How many of you all have raised firemen? Come on. Even more of you. Any of you all an officer? Raise your hand if you're not. See, guys, the education and physical education program is not over with until I say so. Got that? So you've raised firemen, right? So what happens when you tell them don't touch it? Oh, yeah. Hey, y'all, watch this. And if they survive, they're immediately promoted to lieutenant. You got modules of these batteries. Now notice this particular car has 16 battery modules. Each module has 444 batteries hooked up in series. That's just on that car, on a Tesla S. Depending on model, like Ford Lightning, could be twice that, 3 times that amount. This is an incident from Jackson's Mill, West Virginia. West Virginia is really big into the Marcellus shale oil stuff. This was at a well site. The guy had banks of chargers, kind of like what Chief Canterman said. Superintendent comes back in from the well thing, goes into what's called the well house, which is it's basically an old house that's sitting on the well site property. And there was smoke inside the building, wisps of smoke, so he calls the fire department. The fireman, crawling through the building, identifies a lithium where they have all this charging. Notice they've got an extension cord because they want to charge all these cordless batteries and all these cordless radios. He's got to charge them all, got to have them ready for the shift. So the fireman's crawling through the floor because by the time they got there was much more smoke. 2 of the battery packs had actually lit off. These were portable tools. He picks the one battery pack up to take it out, and it explodes in his face. On his Scott face piece, it tore off his thermal imaging camera and tore the bypass valve off of his regulator. What? He survived, but it detonated with enough force to take the bypass valve. You know what I'm talking about, the bypass valve? Took the bypass valve off the side of the regulator and took the thermal imaging camera off the side of the facepiece. Now, they were all aftermarket batteries that blew up. Some of them had just been bought, were brand new, and the boxes for the aftermarket batteries were still there. Again, when you do your education and your outreach, The battery is designed to charge at a specific rate over a specific period of time using the stuff that the manufacturer sent with the battery. I can't stress that enough. Not designed to be charged with 37 other batteries in a rack. Again, from New York, this is last year. Won't spend a lot of time on this because Chief Kennerman spent a great deal of time on it. The issues are coming, but it's not, I hate to say this, and I hope it doesn't offend anybody, but it's ID10T errors. Anybody know what ID10T is? Write it out. For those of you who have a pen, ID10T. It's idiot errors. So if you learn nothing else, you know what an ID10T error is. Again, he showed you this picture. Another one from College Point in Queens where unfortunately there was a loss of life. But here's the problem, and Teresa and I were talking about this last night. It's a huge issue. In my state, for NIFers, we're only required to report structure fires. We don't have to report bike fires. We don't have to report brush fires. We don't have to report car fires. We're required to report structure fires. According to Chief Canterman, only 60% of the fire departments in the United States are participating in NIFers. So we don't know the scope of the problem. There is actually a website called BES. You're going to hear the term you're going to hear ESS. And the group that I work with, the National Alternative Fuels Training Consortium and the National Volunteer Fire Council, and want to recognize the folks over here from GM. They gave the NVFC a very nice grant. We've been going around training people. To date, we've trained about 8,000 first responders. Thanks very much to them. Appreciate it. But we're working on training more. We've taken their awareness level class. We actually have an operations level class. If anybody's interested in it, we actually go out and burn things and blow things up. And have fun. But we're adopting the principle of we're taking away from EVs. Because everybody's focusing on that, and they don't realize there's bigger problems. So we're looking at the term ESS, which is energy storage systems. And whether it's your cell phone, this lovely little tool that they give you, or those big commercial things, it's a means of storing energy, and they have the same characteristics. There's thermal runaway. The issue is stranded energy. There's what's called energy dissipation rates and energy accumulation rates, ACRs. When they go bad, they generate the same bad stuff. And for example, when a lithium battery goes into full thermal runaway and full thermal decomposition, it gives off two gases that you got to really be worried about. The first one is hydrogen fluoride. When we did test burns with commercially available lithium-ion batteries, AA lithium-ion batteries, rechargeable, with the West Virginia Department of Environmental Protection and folks from the EPA, we burned different quantities of them, and we had to stop, and our acceptable burn now for the class is 24 AA batteries, because at 28 we were giving off we had 10 yards downrange, we had 32 parts per million of hydrogen fluoride. And to give you an example, hydrogen fluoride has a permissible exposure limit of 4 parts per million, which means that's as much as OSHA says you can be around. To give you an example, hydrogen cyanide has a permissible exposure limit of 44 parts per million, so hydrogen fluoride is 10 times more deadly than hydrogen cyanide. The other bad thing about hydrogen fluoride is when it comes in contact with moisture, it forms hydrofluoric acid. So anybody in here, an extra man on the truck, EMT? I am a recovering paramedic. I'm a recovering fire chief and a recovering paramedic. I go to all the meetings and eat the donuts. So just... So what do most people do? And we talked about this last week at the safety meeting. What most fire departments, when the EMS responds, they want to treat the person who's been exposed to that with high flow O2, 2 lines, TKO, keep them open. Right? Come on. Remember, this is yes. This is no. Right? Anybody disagree with me? Here's the problem. You have to treat these as a chemical exposure. Because when you give them that high flow O2 on a non-rebreather mask and you start those 2 lines TKO, all you're doing is increasing the perfusion of that toxin, and it is a cellular toxin. It will destroy on a cellular level. So all you're doing is killing them quicker and faster, but by God, they'll have good O2 sats when they roll in the ER. They'll have good systolic pressures. They'll be nice and pink and talking right before they go into rapid onset chemical pneumocystis and end up in the ICU. But you ever notice that you never see a death certificate that says died in the ambulance? They're either dead on scene or dead on arrival. No one ever dies in an ambulance. So, the other chemical that's given off is what's called phosphorofluoride. Now, phosphorofluoride has some unique properties. It loves to bond with hemoglobin. Loves it. Won't let go of it. It'll hang on to the bloody bitter end. You basically got to put the patient in a hyperbaric chamber to get the phosphorofluoride out of them. It also forms phosphoric acid whenever it comes in contact with moisture. And everybody goes, see, I told you this. EVs are dangerous. But what if I told you you get the same thing if you burn flammable refrigerants? Like in your air conditioner, in your refrigerator. The isobutane. If you don't believe me, Google. They killed 2 people at UL testing flammable refrigerants because they didn't think to test for hydrogen fluoride. To my knowledge, I don't think anybody's been killed testing an electric vehicle fire. Not that I know of, because I've researched the heck out of it and read stuff from Sweden and Norway. Ate my score while I was reading it. But what if I also told you that with a regular vehicle fire, you're going to get polyvinyl chloride, which off-gases, which forms hydrogen cyanide, organic peroxides, all this other stuff. That when you spray water on it, you're going to put it right back in the water stream. And the Department of Environmental Protection says it's ancillary. It's not going to create a big problem. And you're not going to have a huge problem with an electric vehicle fire. Yes, there is toxins present, but I guarantee you right now, if I tested that table with fluorine paper and everything else, I'd be willing to bet I could find what are called PABs and PACs. Anybody know what PABs and PACs are? They're called persistent bioaccumulating chemicals. Ever heard that term? That's what the whole fire department foam lawsuit's built over, PFAs, PFOAs. But if I tested this table right now, this bottle, you're putting it to your mouth every day. But there's what's called an acceptable risk, a permissible exposure limit, time-weighted average, threshold limit value, all that other stuff. So, there's reasons why these things go bad. Yes, they can have mechanical failures. Not typically, the internal mechanical failure is caused by some external action. Damage to the battery. There's a documented incident out of Mecklenburg County, North Carolina, where a lady drove over a deer in her car, electric car. 10 minutes later, she pulls over, calls 911, says, my car's filling up with smoke. Well, when they actually did an analysis of the vehicle, yeah, the car burned. A deer hoof had gone up through the battery. She hit it here. Okay? Design flaws. You see that a lot in batteries that are not, there's a reason why you're getting a cheap price on a battery. It's not because they love you and they want you to have a better battery. The moisture level too high in the battery. There's a lot of these batteries, different cells and different compartmental configurations that some of them use regular antifreeze to cool them. They use ethylene glycol, propylene glycol, other stuff. There's certain battery technologies that use what are called gel emulsions. It's like pumping jelly through it because it absorbs heat and has the ability to absorb a lot of heat in a short time and moves it through it. I was showing Chief Canterman and Teresa last night a picture of a school bus that has a heat exchanger on it. I kid you not. I could point you to the article. It has this heat exchanger on it. It's by a company that's breaking into the bus market. They said, well, the problem is that there's no link between the battery and the driver, so the battery doesn't know when. And it was a well-maintained bus, wasn't it, Teresa? The whole heat exchanger's covered in mud, dust, and the radiator coils are plug full of things, which goes back to poor maintenance. And they were like, well, this thing, the battery heated up and they had a problem. You know what the manufacturer's suggestion was for dealing with the problem? You want to tell them, Teresa? Put a smoke detector in the bus. What the fuck? Put a smoke detector in the bus? The school bus that your kids ride on. Abnormal or improper usage. I felt really good last night because I educated Chief Canterman about something that he wasn't aware of. How many of you have ever heard of a prom chip? I know you guys have. Performance, realignment, something. But your car, you buy your electric car and it tells you, recommended charging time is X. Remember, I go back to commandment number 1. These things are designed to charge at a specific rate over a specific time. But I don't want that. So I go out there and find the computer of this thing and I buy me a chip online. And I pull the factory chip out and I put this other chip in, which allows me to charge it completely differently. And you can buy them. The one we looked at last night is about $350. But look, I don't have to wait for my car to charge. It's fast charging. What if I told you that they're actually racing these cars and they're selling all kinds of modifications to race them? What? Have you all heard of that? There's actually Electronic Vehicle Racing League. What now? I don't know how it would do, but I'm just telling you. So they do this stuff, and California's actually looking now when they do their inspections that they're going to actually pull the thing and make sure that it's a factory chip inside the car. That legislation has actually been discussed. Because there's so much, they call it gray market and aftermarket stuff, if you really want to soup your car up, go buy a 68 Camaro, go to the Holly website, go to Hooker Headers, buy that, Maybe it's just me being from West by God, Virginia, but it is. This is what an EV battery cell looks like after a fire. Looks like a bunch of AA batteries that just had a bad day. Because it becomes a chain reaction, a catalytic response. That's what they look like up close. Notice the ends of them are blown out. You got to understand there's a cycle to this. They do a lot of R&D testing. I would say on average, when I was in Alabama, I met with Honda and Mercedes-Benz. I've worked with folks spoke to the gentleman from GM. We were on a webinar together with the DOT and spoke to people from Lyon Bus Company and some other things. I'd say before the thing actually hits the road, there's probably 5 to 6 years of testing that goes before on it in most cases. So there's a lot of R&D that goes on that. Then they go look at the assembly and things. There's quality control measures along that way. And again, I'm not defending that industry. I'm telling you it's the same if you go to the Ryobi factory outside of Charlotte, North Carolina. There's the same thing that goes on there. There's R&D, there's quality control testing, there's component assembly, distribution center, the retailer, all this stuff around. It goes back to the discard stuff, which is how Morris, Illinois happened. Okay. Thank you all very much. Okay, I want you to know about stranded energy. I want you to know that if you approach these vehicles and there's an event going on, make sure that you wear fire gloves. Don't use rescue gloves because the rescue gloves may not provide arc protection, and depending on how the battery's damaged, it may energize the whole car. Same with the home energy system. Got to pay attention to that. And thermal runaway, it's a thing. I'll be more than happy to answer questions on a break. That's what 24 AA lithium-ion batteries look like. Anybody want to know real quick how we set them off? We hit them with a 2-pound hammer. No external ignition source. Yes, you have a question? That's what 24 did. Frag distance of about 100 feet. We had projectiles came out. Some of the projectiles came out of the battery pack at 540 feet per second. So, if anybody has any questions, we'd be more than happy to talk to you afterwards.